Thank you, Sarg, and thanks everybody for coming and joining us today. We're really excited about what's going on in WiSun. I think that the opportunity here for a really interoperable network and a lot of the security thought that's been put into it and the framing of using existing open standards and putting it into a nice profile is a good playbook for success in this smart utility space and hopefully growing into smart city in a wide range of use cases. So what I'm going to do today is talk a little bit more about the security perspective of WiSun, how we're addressing device identity and other risks in the environment, and then getting a little into the implementation and considerations for how do you actually put this into a device or a ecosystem. So a little more about GlobalSign and some perspective here. GlobalSign has been a certificate authority for around 20 years or so, and the certificate authority is really responsible for verifying identities and issuing credentials to those identities. So we use this expertise in PKI and identity and access management to build high volume, scalable solutions to secure some of these ecosystems. And Nisarg and I work specifically within the IoT group in GlobalSign, and so we're very interested to collaborate and work with utilities and manufacturers and other partners in this ecosystem to really build security and identity in from the design level of a lot of these solutions. GlobalSign, we're around 400 people, maybe 450 worldwide. We have offices in Tokyo, Singapore, Shanghai, India, Russia, Belgium, UK, and US. We've been serving a large number of certificates for a number of years here, and you can see some of the stats. So I'm going to get right into some very general security overviews, and I'm not certain kind of the level of expertise. So forgive me if this is too remedial for some of you, and hopefully it's useful for others. But if we look at a general scenario of what happens if you don't have identity in an ecosystem, and this is a very simplified architecture here where we have a device and potentially a gateway and a cloud service, and there's some type of connectivity and communications going on between those. So one risk is where an entity can impersonate another. And so this is really where you need identity so you can know that you have a trusted actor to talk to on the other end of the line. Without identity, you're also at risk of compromise. That gateway can now be compromised and used in malicious or non-standard or non-prescribed approaches. You can lose data. The communications between the network can be disclosed, and that's potentially damaging depending on the types of data you're communicating with. And then furthermore, I think this is one of the areas that's tremendously risky and also interesting. What the IoT brings to this marketplace is the control of these devices. And so once there's actually centralized command and control, this is really where identity is essential to eliminate some of that risk of, these are cyber physical systems now, and that physical command and control of those is really important to secure. And so if we look at a scenario where, we simplified a little bit, where a device is sending data to a cloud platform in plain text, these are some of the risks in a little more detail. So a rogue actor in this scenario, if that data is not encrypted, can eavesdrop and potentially record that data, whether that's then used for a replay attack or another mechanism. That's a risk that you probably don't want in your ecosystem. Another scenario here is where that man in the middle can now change the data in translate and represent that they are potentially the device and present that to the cloud. And this is, whether it's sending something, that might be considered trivial, like sensor readings from, one sensor out of a million, or something more sensitive, that's definitely a risk that you don't want in your ecosystem. And how do certificates or identities start mitigating this? And so the core component we're talking about is using certificate-based authentication with mutual TLS. These types of scenarios are avoided. So where the device and the cloud or whatever actors it's talking to, whether it's another device, they have identities that can be used to establish A, trust between them, and B, communications that are private and encrypted. So in this scenario with a mutual TLS, the device and the cloud are both authenticated and the communications are encrypted. And so how this is done is really kind of folding into the details of the life cycle. And I'll get into that a little bit further. But in general, the way this works is, the entities and the actors in the ecosystem will be configured with a root of trust. And this is basically saying, you can trust anything that's presenting a certificate issued from one of these entities. And so during a handshake or a connection communication session, those actors will present their identity certificate, and then the receiving party can verify that that identity certificate chains up to a root of trust. And so in that session, you can know that the actors are coming from trusted entities, and they're able to leverage their credentials to bootstrap encryption and all of those good things that you want for a secure ecosystem. And how PKI really supports this YSUN spec and the YSUN field area network specifically is PKI. It's really tried and true. It's one of the longest identity and information security cryptographic technologies used today, and it's been used for the past 20, 30 years to secure communications. And it's really an information security Swiss Army knife, as we talk about it sometimes. And using PKI and asymmetric cryptography and X509-based credentials, you can really bootstrap a whole range of these attributes that you want in a secure network. So one, authentication, so that you can ensure the identity you're talking to is trusted and not spoofed. You can encrypt those communications so that man in the middle or malicious parties can't determine the data. You can have assurance that the data has not been modified in transit, that you have data integrity. And you can also bootstrap into more advanced authorization and access management scenarios using these credentials. In addition, PKI is really probably the largest example of identity deployed today. So whether it's the Department of Defense's PKI ecosystems or the existing SSL infrastructure that's used to secure websites, it's really demonstrated its scalability. And so this is really important when we look at the vision and future for what YSUN is trying to achieve. We starting with components of the ecosystem, but when we're expanding into smart city components and we're talking hundreds of millions of entities per ecosystem, this is something you need in your security solution. PKI has demonstrated that it is scalable today. And it's also interoperable, and so this, I think, folds directly into YSUN's story and approach, is that right now PKI and X509-based identities are naturally supported in the range of software and services that are built on the internet today. And so there are going to be changes to how the specific actors integrate, but it's already supported in a wide range of that infrastructure already. And it's also really the strongest authentication and identity mechanism compared to others. So compared to username and passwords or shared secrets or public key only cryptography, these all start to fail over when you talk about the scalability and the ability to address these future scenarios of the networks. And so what is X509 in a little more specific detail? So the world standard for device identity really is an X509 public key certificate. And it's an electronic document, just a file that it's a standard base from ISO, and it contains a range of information. So what you put in that certificate is really going to be dependent based upon the ecosystem, and YSUN has some specific guidance in their field area network specification on what needs to be in there. But it may be information about the manufacturer, the operator, the device specifically. But importantly, it's cryptographically verifiable, and it uses asymmetric cryptography rather than symmetric cryptography. And these are very important things, because in asymmetric cryptography, the secrets always stay secret. And it's also a much more scalable method than symmetric cryptography. And so you reduce a lot of the risks over key management of the symmetric keys in this scenario. And these documents are cryptographically verifiable in the sense that they can't be modified without losing their integrity. So if you get a modified certificate, you can run a cryptographic check that makes sure that this is what it was when it was signed. And so a little more detail, it's binding this information to the owner. So if we look at an analogy, it's kind of like a driver's license or a birth certificate, where there's a trusted entity, whether it's the DMV or the hospital, that is binding a certain amount of information about an individual to a document or a credential. And so this is really kind of a good analogy to get this in your mind, what an X509 credential does. It shows this is who you are, and it has an actor or entity that's verified it, and it's difficult to manipulate or modify. So getting now into the specifics over the WiSun fan spec and how certificates are folded into there. So as Phil mentioned, the fan spec leverages a lot of existing standards from other organizations. So the core identity source or standard for WiSun fan is the IEEE 802.1 AR Dev ID cert format. And so this has some specific attributes. So in this case, these certificates are indefinite in their lifetime. And so the FAN 1.0 is really prescribing this initial device identity certificate that will be included from a device manufacturer at the time of manufacturing. So you can have essentially what we could call a birth certificate for the device. So you have a notion over authenticity and a provider of that. So this gives you a custom WiSun iDev ID that has a few profile layers above what the IEEE standard gives you. And in this ecosystem, GlobalSign will be operating hierarchies for the production issuance of FAN certificates as well as the test certificates in that ecosystem. And there's a number of deployment options that I won't get into the whole granularity today, but after the talk, I'd be happy to talk about some specific areas of implementation or how you're looking at to fold this into your ecosystem or your manufacturing environment. So these long-lived device identities will be installed by the device manufacturer, and we'll see this term iDev ID, which stands for initial device identity, and you can think of this as a birth certificate for the device. And really this birth certificate, it can be used in kind of that whole range of scenarios I described there for authentication when operating in the network, but really kind of the best practice is going to be to use this certificate as more of a bootstrap into a trusted credential for operation. And so this is something that I think we'll see in the FAN 2.0 spec, where there are multiple notions of credentials and identities that will be used as the devices transfer from a manufacturer to an operating environment. These devices in the WiSun FAN certified devices must support 3 roots of trust. So this supports some flexibility in how these ecosystems are going to be operated, but one of those must be the GlobalSign root to ensure some of this interoperability goal. And so GlobalSign will be offering these PKI services and working with device manufacturers to get these PKI operations off the ground. And like I mentioned, so the devices will use this initial device identity for secure communications and bootstrap into mutual authentication, potentially with other credentials on the device. And so this is getting a little more into now the nuance of how do you actually fold some of these nice technologies into a real world environment, and what are the different concerns or considerations for how you achieve a strong device identity in your environment. And so when you think about a device being built and manufactured and then sold, there's really a number of stages of that. And so this covers some considerations for how certificates fold into this life cycle. And so one is at the manufacturing stage. And so this is generally a stage where you obviously build the hardware components into it. There might be some diagnostics that go onto the device, that flash firmware or the initial initialization or diagnostics of the device. And this is generally the stage that we see where the roots of trust would be installed into the device or pre-configured, as well as the initial device identity being configured. And there's a number of options for architecturally how this is injected. GlobalSign operates cloud services that can be connected into manufacturing environments, but also a lot of manufacturing environments will want to run those on-premise in a more closed environment. And so there's a range of architectures that tie back to that certificate hierarchy that can be supported. But really one of the keys in this manufacturing environment is kind of parlaying now into some of the next presentations you'll see is how those private keys for the devices are being protected. And this is a very important consideration for building a strong device identity. So PKI is one component, but then the cryptography for protecting those keys, the hardware level security or software level security of those keys is essential as well. And that really needs to be folded into, like Lila mentioned previously, the design of these products, and from the ground up, really looking at these range of considerations. So from the hardware through the software to the connectivity is really the security story everybody needs to be looking at now. But so after the device gets manufactured, there's now a sale or a deployment or an enrollment in an operator's network, utilities network. And this is a critical part of the device identity, because this is where it really starts getting used and the value of a security posture comes to light. And so in this enrollment and operation, there's now new architectures for how this enrollment is happening. And so most likely these enrollment services will be coming onto the cloud. This is the stage that we would see the initial device identity being leveraged into a local device identity. And the local device identity, we can think of more of an access credential or an operational credential. Yes? Oh, I'm sorry, yes. That was supposed to be, my fault. Yep. So the iDev ID would be used to bootstrap into a local dev ID. And kind of the main distinction between those identities is that the iDev ID is much more longer lived. It's usually an authenticity of the device. And the local dev ID might be something that's owned or run by the operator network or the utility network. And these are often shorter duration in their access. So you can continue to roll these as the device is operating through its life cycle. And so in this, kind of related to the life cycle of the device, there's a lot of new considerations for how security, these traditional information security technologies are being applied into IoT environments. And so we talked a little about the key generation concerns or considerations. So you want mechanisms that protect that key, protect the key generation process, and Intrinsic ID, and Louis will show you some of the unique attributes that Intrinsic ID has with their SRAM PUF technology to protect that. But also looking at how these technologies are affording unique identities, shared identities amongst devices is something that will leave you ripe for things like the Mirai botnet attack that you've seen, where compromising one device potentially gives you access to a whole range of products or devices. So unique identities are really important in that scenario. Folding this into that manufacturing environment, and there's a range of architectural approaches for how do you centralize the key management or the certificate issuance for devices into an environment. How do you automate this? Because obviously once we're talking about tens of thousands, hundreds of thousands, millions of devices, this is not something that you're going to want a human in the loop on that. And the scale, the size, and the scope of your ecosystem is really important. These will drive some of the more unique features or attributes of a PKI deployment or a security deployment to meet your needs and requirements. Looking at the physical security of the devices, and this parlays back to how you protect those private keys. What type of assurances will you have over the physical security of the device? A lot of the times these, you won't have any, and so you need to understand that, what type of risks are you entering or allowing by protecting those keys or not protecting those keys if you don't have physical security of the device. And then also specifically in this utility space, the devices, have 15, 20, 30-year lifespans, and how does your technology afford that longer-lived attribute of the environment? So I'm not saying that there's architectures or blueprints for all of these right now, but these are some of the things that GlobalSign and Intrinsic ID and Renesas work with partners on to enable and look at, and they're core considerations that a lot of the YSUN fan spec are looking at as these ecosystems are growing. So we talked about securing the keys. So there's a really important role of hardware and software level security to protect those keys. And the goal really around here is to prevent the identity migration and impersonation of devices in the environment. And the other big change from enterprise IT security into operational technology security is now you're looking at much broader diversity of operating systems, software, hardware level components that you're now dealing with constraints on devices, you're dealing with limitations in connectivity, and all of these new features or variants of devices that really impact how do you implement this successfully. When we look at an enterprise IT environment, you're talking, a handful of operating systems. Everything's very standard, but once we get into IoT environments and these new networks, the diversity is huge. And so the way you approach this is also going to be different. So maybe you're looking at augmenting the software libraries or hardware components you're using. There's no more real plug and play anymore. And the trust models are also evolving. And so this is something we look at with WiSun here, that they're starting to build a next generation trust model. And so this is leveraging a lot of the concepts from an existing PKI deployment, but not necessarily using the same hierarchies or the same formats of identities. And so how GlobalSign is really positioned to support this is GlobalSign has rebuilt our infrastructure over the past 4 years, specifically targeted at this high scale opportunity that we all see in the IoT. And so we leverage a lot of our security competencies and expertise. So we operate our own data centers. We're focused at running HSMs and the CA services, the RA services that are all required for scale in these environments. And this is kind of our core focus. These are WebTrust audited data centers. We have offline CAs with key management processes that all fold into here. We have a service that we've built to really afford redundancy. So when we look at you can obviously run PKI systems on your own, but how do you get this scale and redundancy and the disaster recovery? That's something that's non-trivial to address in those environments. And so this is one area where GlobalSign's cloud-based identity issuance services are really suited towards the growth and opportunity in this IoT market. So the scalability is a core tenet of our platform and design now. So we have a modern RESTful API with high volume and throughput. We can issue around 3,000 certificates per second on the platform today. But this is something that's elastically scalable based upon the market requirements, and so we can grow this up as the market and when the market needs it. And we also have been building out more flexibility for enrollment of these devices in the actual environment. So there's, like we go back to the life cycle, there's different considerations for the manufacturing environment versus the operation environment. And so this is where GlobalSign is supporting this ecosystem, in addition to these custom PKI hierarchies and trust models that organizations like WiSun are bringing to support. And so a little overview or architecture diagram of how GlobalSign supports this. So the core of GlobalSign services is a cloud-based certificate authority PKI ecosystem. And then we deploy this either through a manufacturing facility with edge and roll proxy services that communicate over to devices in a range of protocols, or we look at a brownfield or in-field deployment where that similar component is helping to proxy the IoT device enrollment here. And these components, this EdgeGS GlobalSign Edge and Roll, may be deployed on-premise in a customer environment, or it's something that we can host and run in a public cloud as well. And so there's really, to get into some of the details of how this works will depend on the specifics of the device environment, the specifics of the connectivity or the communications. And so would be happy to kind of talk about any of those details with you one-on-one after this session. And so to really kind of support and foster the trust models in the WiSun ecosystem, as Phil mentioned, GlobalSign's been selected as the third-party CA, but we're really looking to partner with this community and build this security into the products from the ground, because we really would like to see the success of a very security-minded framework and standards approach like WiSun brought in the market. And so GlobalSign's here with some of our other partners, Intrinsic ID and Renesas, and really the core behind this is, there's no single point solution that's going to address security. To build a secure product, you really need to build a partnership and deploy this into the market together. And so that's really kind of what we're looking to demonstrate here today. And so in light of that, GlobalSign has a IoT developer program. So we have a range of partners today that really can help to get into ecosystems and work with the specifics of that environment to deploy these standards compliant solutions into the different environments. So we can work at a very low cost to enable pilots and proof of concepts and help sell within your organization, but we also support through joint marketing and demonstrations. And we really are aware of kind of these IoT use cases are starting to get off the ground, and there needs to be a lot of organization buy-in and prove that these models work. And so that's what we're really looking to do, is partner and help these organizations and deployments get them together. So that's kind of what we have today, and so we'd be happy to have some further discussions during lunch or after, and we have some great demos, and if you have any questions, we can take them now, but thank you for your time.
Thank you for watching this GlobalSign presentation. For more videos on identity and PKI, follow one of the links on your screen. And don't forget to subscribe to our channel to keep up to date with the latest video content.